right now, and the sample I'm using actually is an aluminum 6061T6. It's the same sample that we use for other experiments like the tensile test or the shear test. So this is the torsion machine, pretty much like the Instron that you've seen for tensile or compression tests, except that this one, instead of applying the load and measure the deformation, this one actually you're applying the torque and you're measuring the angular rotation. So, as always guys, remember that you need to have your safety glasses on, right? I'm going to put this down, so put my own glasses. Some of the things that you have to remember, guys, is to measure the diameter of this specimen, which is about 1/2 inch. Now I just want to also mention that these stocks, when they come in, is in the hex shape, as you could see here. But then we send them to the machine shop, and then we machine them, make it nice and smooth, because this is actually the torsion test of a circular section. Torsion tests of non-circular sections really don't have much of application. So a meaningful torsion test would be done on a circular section. The only reason we keep the hex at the end so that we have a good grip. Okay, so measure the diameter. Also, you want to measure this length, which this length is going to be used for calculating the shear strain, gamma. Okay, and you'll see the theory in the video or in the class at some point. Okay, so what you want to do is to place your specimen here, and then make sure that you put this guy up to where the tapering is, and you want to make sure that this guy is in such a way that the jaws are hitting the flat, right? And then you tighten this up as best as you can. Okay, now you want to push this so that it falls on the other side. Okay, again, make sure that the jaws are in such a way that they are or the way you adjust the length so that the tapering is right on this edge. Okay, so from tapering to tapering here, and that's the length by the way you need to measure. All right, now remember that we could only rotate this if this safety glass is closed. Okay, so we want to make sure that the jaw here is kind of hitting the top, the flat part, so we have a nice grip. So I'm going to rotate this accordingly. Either it looks like I gotta go the other way. So now I think I'm going to close this, open this and tighten this up. Again, try to tighten it up. Otherwise, you'll see a lot of slippage, and you don't want to see that, because then you have to stop and start a new test. Now, before you do this, it would be nice actually to draw a line here using a Sharpie, right? I'm not good with drawing straight lines, as you could see, but I'll do my best. So draw a straight line. The reason we do this so that as this rotates and eventually will fail, we'll see how many turns this guy is going to go through before the failure happens. Now I'm assuming that I've done a good job in tightening this. So one more time, I'll do this neurotic. I want to make sure that everything is nice. Okay, we're ready. So the test, by the way, the program is called torsion test. And remember now, we have to call the data file, the file that is going to contain all the data, all the the Excel data. And I'm going to call it something unique. I think we called it before pandemic. Hitting the start button, and we're ready to go. Okay, it's accelerating. Now, about 2 revolutions. You could see the black line, like a straight line, now it's curving. About 600 degrees, and soon it will fail, I believe. It's like a very strong sample of aluminum. Getting to almost 4 revolutions. Just past 4 revolutions. Getting close to 5 revolutions. Just past 1800 degrees. Just past the 6 revolutions. Just past 8 revolutions. Okay, failure happened after 8 revolutions. I have to be honest with you, this is an exceptional aluminum, in my opinion. I've seen maybe 2 or 3 revolutions, but not 8 revolutions. So this will tell you actually, how it stocks, when you get something, materials, even though they're supposedly 6061 T6, but they could be totally different. But in any case, guys, once you're done, one thing to remember, guys, is that you want to actually continue with saving your data file. So you go through the next. You don't have to put any information regarding the diameter or anything. You don't need those. And then make sure you always finish at the end. Very important, guys. Click on the finish, and then you will have your data file saved. So let me show you where that data file is first, and you can then take the sample out and take a look at it. Okay, so This is always, the data file is always make 2500 data. And remember, it's going to be in a folder. I named it something. So the folder should be up here under my name. And then the specimen data file is here. And you have the data of load versus, torque versus angular deformation. Remember that this is in degrees. In the calculation, it has to be converted to radians. So let me just take the sample out and take a look at it, see what has happened. You can see the number of revolutions. So, by the way, if you touch this, it's pretty hot because of all the energy is being dissipated. So let me take it also from this side. All right. So take a look, guys. You don't see really anything. It's broken flatly. There is no such thing as 45-degree angle, right? That's the nature of torsion. And then just keep in mind that by putting those that straight line, you clearly could see, how many revolutions this guy has gone through before it has failed. Of course, the data file will, show you exactly the same thing. So this is it. This is our torsion test. I hope you enjoyed it.